Well, good afternoon. It's the PFG Live from New Hampshire. Welcome aboard. Hey, Wes, good morning. Nice to see you. Kevin, welcome. Jello, thank you. I think lime. I'm going to go with the lime Jello this morning. How is everybody today? Been down in the shop all morning making minis for Mr. CJ Stevens, who's not here yet or hasn't checked in. But yeah, I hope everybody is doing great. It is a very, very rainy day today in southern New Hampshire, and that's totally fine. We needed it. We needed every bit of it. So indoor stuff has been the choice. And of course, today is brought to you by PFGstones.com. They're PFG, and so can you. Let's see. It is the 23rd of April. Good afternoon, Carl. Gray and rainy in Rhode Island, 50 degrees. Thank you, sir. Currently in the southern New Hampshire, we have 45 degrees and raining. It's been raining all day. And that's okay because we have a shop and we can get more work done the more rain that falls. So I assume that the audio and video is good. The audio is looking a little hot here, but I think we'll take it. Flat Lapper, welcome back. Nice to see you. Okay, so this is true story. I'm doing all my tech here. I'm getting all my buttons pushed, getting all the screens all set up. Oh, this just in. Mr. Kevin Blodgett reports 55 degrees Fahrenheit and cloudy in Oregon. Yeah, I don't know. So what do we, you're actually warmer than us by 10 degrees. That's either that's surprising or it's not. So I'm getting all my tech sorted out here, and I forgot to mute my phone. In fact, I got to add that to my checklist. I'm literally taking a note right now. So the phone rings. Flat Lapper reports 39 degrees and overcast. You got to give me your location. See? Temperature, sky condition, location. Audio clear from Carl. Thank you. Robert Simpson reports 46 degrees in Detroit and had to turn the heat back on this morning. Well, yeah, welcome to our world. We go through this period, it's right about now, when we turn on both the heat and the air conditioning and let it fight it out. K-Bonk is with us and reports 67 and mostly sunny, honey. And that's the Philadelphia. Yes, you got it in there in time. Excellent. Northern Illinois. Flat Lapper is Northern Illinois for his 39 and overcast. That's chilly. So I was working in the shop this morning. I hit the end of a cycle on the CNC grinder. I got everything stable, turned off the mist collector, came upstairs, got all my screens going. And with about 3 minutes to go, my phone rings. And it's my good friend Paul, who lives up the street. I should have recorded it. And he says, "Excuse me, I understand you're somebody that can help me determine if something is flat." I said, "You called the right place." So Paul has a 3D printer, and he is having some problems with his first layer in this particular printer. And he said that he heard that some people are getting build plates which are not flat. So he wants some help with flatosity. And I advised him that he did, in fact, come to the right place. So actually, when the PFG Live is over, Paul's going to be over. We're gonna check his flatness. I'm not judging. So Paul's a good customer of Kinetic Precision. Let's see, we did some welding for him to fix a chair. That was a year ago. So he's not doing too bad. I joke that we also repair boat parts during the winter, because I have a buddy of mine who is a sailboat guy, and we've built a lot of sailboat parts. and that happens usually during the winter. So anyway, welcome aboard. It's a good shop day. We're getting a lot of stuff done. And if you've been following along on Instagram, you know that I got a couple of interesting projects done this week. One of them was the grippers. I make my own grippers. I will judge it at temperature. I make my own grippers that go into the Mighty Bite Versa Grip system. So I don't know if you're familiar with. This just in. Guy Brush says 12 degrees centigrade or Celsius, depending on which side of the street you're from, and showers in the UK. Welcome aboard, sir. So that means it's getting close to dinner time for you. Nice to see you. So I make my own grippers for the Versa grips. So Mighty Bite, by the way, Mighty Bite is a New Hampshire company. Hashtag not sponsored, but I like them. And they make a couple of systems. One's called the Talon grips, which are these straight, grippers that go in a jaw that they also designed that has a groove and has threaded holes, and you put the grippers in. But then they have another one called Versa Grip, which is circular pockets in the vice jaw, and you put in another gripper that can rotate, and basically it's set up for holding round things or interesting shaped things. So I have the Versa Grip system, and the Mighty Bite Versa Grip system is excellent. And the way, when you put a round thing in there, it locates on top of the jaw for Z height. I'm sorry, for Z. And then the gripper, grips it from the side. Whereas I was having a challenge in making my B200 balancing rings. So the B200 balancing rings start life as a hockey puck of steel. We make them out of 12-15 steel. And they start life as, I'm going by memory here, I think it's a 1/2-inch slice of 2.5-inch diameter steel. I could be a little off on that. It might be 2 3/4. But if you just use it the way the Versa Grip, the Mighty Bite Versa Grip is intended to be used, the holes that I have to drill and tap some of them are right over the vice jaw. So what I did is I designed some grippers that are taller, that lift the part up, okay, and leave some air under it, except for the 4 grippers that grab the edges. So I've been doing that for a while, but I had a new batch coming. In fact, we're down to 0 inventory on the B200s, and I needed to remake the grippers because my heat treating on the last batch of the grippers was terrible. So I'm holding this up to the camera. This is if you're watching the video. If you're listening to the podcast, we're just going to have to imagine this in your head. But there's the gripper. You can see the nice profile. Okay. So the gripper provides a little shelf for the part and the knife edge that goes into the side of the part. Well, when I first made them, I don't think my heat treating foo was up to snuff, and they cracked with too much pressure. So I retempered them, and basically I got them to work, but I never liked it. So I've made some new ones. Well, lo and behold, we learned, we did some new heat treating procedures that we hadn't done before, which is pretty cool. Again, if you're following on Instagram, these are made out of A2 tool steel, and I went ahead and hardened them in stainless pouches, and we did a few new things. Number one, I got a new oven. I've got the new Hotshot 360 Professional or Pro. So let me go off on a tangent here. a number of years ago, Stan Zinkowski of Barzy Industrial, hi Stan, came up with this, designed and built this lovely small heat treating oven, which I bought one of and I love it. And if you haven't seen them, they're really pretty nice, and they're very small. And Stan did a lot of good work on the insulation and the heating elements and everything, and it came out great. So I bought one. Time passes. Stan sells the oven business to American Rotary, another good company. American Rotary, I think they call it American Kiln now, but they reinvented Stan's design, basically took Stan's design but just added a few things to it and literally made it even better. So my buddy Adam, hi Adam, who's in Massachusetts, I still like him though. He sends me a message one day of this Facebook Marketplace find of the new American Rotary Hotshot 360, which has the new touch screen, and it hangs on the network, and you can monitor it. And this guy had it. So of course, Adam starts trouble. He sends me these things. So I call this guy up, and he says he won it as at the New York Maker Faire. So they raffled it off, and he won it. And he's a woodworker, and he never plugged it in, and he just wanted to sell it. So I bought it from him, brought it back. Make a long story short, that oven is truly even better. It's bigger, but they added some insulation so it doesn't get hot on the outside surfaces, and some airflow. Nice engineering. So anyway, that was the first thing that was new. The second thing that was new is I took my A2 parts and I did a couple of things that I'd never done before. I ultrasonically cleaned them before heat treating to get all the skin oils and stuff off of them. I put them in a stainless steel pouch. The ones I use are called VACPAK, VAKPAK. They're laser welded on 3 sides, which is really nice. And then I'm standing there, I'm getting ready to start this cycle, and I look over and I'm standing next to my argon tank on my TIG welder. And I'm like, the level of effort required to purge this pouch and put argon in it is like zero. Let's do it. So here's what I did. I took the tungsten out of my TIG torch. I turned on my TIG welder. I turned on my tank. I brought my foot pedal over, and I went ahead and I hit the foot pedal, and I started pouring argon out of it. And I sort of tilted the pouch up, and I started filling it with argon by sticking the torch in it. And I waited a minute or so, and then I yanked it out. I reduced the volume of the pouch and immediately started folding the closed end. So pretty much I would have gotten out most of the oxygen. So that was the second new thing I did. So then we went ahead and ran the A2 tool steel recipe on the oven. Now, one of the things I dearly love about this new oven is you can store multiple recipes in it. You could pick it with your finger with the touch screen, and it works great. So I have an A2 recipe. So I started my A2 recipe and I let it run. The next thing, so when that cycle was done, it came out, and I posted this on Instagram, and I went onto my homemade rack, and now I have a fan next to it. And I was needled by a certain guy named Robin. Okay, hi Robin, and he correctly pointed out in my last round of heat treating lessons that having a fan is a good idea. And after reading and thinking about it, I agreed with him. So I have this fan I set up, and if I may take a small tangent, this fan was on top the topmost surface of a 19-inch wide, 6-foot high rack. This rack was one of 2 computers that I was given that came out of MIT, and it was the first Lisp machines. And these were foundational in the development of some of these high-end computers. It had a processor that was literally about 2 feet wide. Well, it couldn't be 2 feet, 1.5 feet wide, and about 3 feet tall. A wire wrap board of logic. It was amazing. But anyway, because of circumstances, none of that is in my possession anymore. But of the things that are still in my possession is this fan, which was on top of Catter 6 or Catter 7, one of the 2, because I had both of those, and my friend Steve gave them to me. Hi, Steve. And so that became my heat treating station fan. Works great. Back to heat treating. So we come out of the oven and we put it on the rack and we start the fan. So something very interesting happened, which caused me to, I wouldn't say panic, but sort of change what I would have otherwise done. What I normally would have done would be put the thing on the rack, and usually with flat stuff, like these these flat blades, which came out like lasagna noodles, which we're going to talk about in a minute. But with flat stuff, you can see the outline of the flat thing, and you can see the red hot outline of the part. And I would put it on the rack, and I would wait until the red is gone before opening the pouch to avoid oxidation. Here's where it gets interesting. The pouch comes out, goes on the rack. I'm putting down my implements, and I look at it, and usually it looks vacuum packed when it comes out of the oven. And it's not vacuum packed. It looks a little puffy, like it went in. It looks like it went in. And I get a little, this is all happening in seconds. This isn't like it's taken a long time. It throws me off my game because usually you can see the red hot parts through the foil because they're touching the foil. I cannot see it because it's still puffy. So I didn't have time to figure out why it was still puffy. The reason is very interesting. So I waited maybe a minute, might have been as much as a minute and a half, and with no guidance from the color of the part, I cut the pouch open and I dumped the parts onto the rack. Well, the parts came out dull red, so they were still red hot. And they ended up turning into this lovely gray oxide coating. Now people have pointed out to me that this is actually looks pretty desirable. And I have to tell you, from handling the parts, it's really nice. It's a very smooth, it turns out pretty thin oxide coating. And I'm like, this could be useful. But it wasn't what I wanted, but it was interesting. So now let's analyze this. What happened? Well, what happened was when I did the argon purge, I removed all the oxygen. I put all in quotes. I removed all the oxygen from the pouch. Well, the way these pouches work, the pouch is made out of 309 stainless steel. 309 stainless steel at these temperatures reacts with oxygen at a lower temperature than everything else. And therefore it scavenges up. Yeah, K-Bonk, it very much like a rust blue in terms of desirability, definitely a different color. But honestly, it came out really great. So we're going to have to figure out how to make that process repeatable rather than me just panicking. So anyway, it came out of the pouch and it went onto the rack and it cooled off. So what was going on was the argon purge in the pouch removed the oxygen. The oxygen, which normally there's a little, little normal atmosphere when you close up the pouch. The pouch itself, the 309 stainless, scavenges that oxygen, and it reduces the pressure in the bag. It literally is removing gas in the form of oxygen from the bag, and it comes out looking like it was vacuum packed. Well, there was no oxygen in the bag, so there was nothing for the 309 stainless to scavenge. That's why it came out a little puffy. K-Bonk says, wonder if carding it would do anything. I'll get back to that. I have something to say about that. Carl says, so the stainless is gettering. Excellent. Oh, Carl, you're awesome. Carl is correctly using the word gettering. Is gettering the air. Yes, yes, yes. So these stainless pouches that we get and the stainless tool wrap that we use in heat treating is not some random stainless. It is a specific alloy designed to be a getter, okay, to scavenge up the oxygen during the heat treat process, so your parts don't have to. So it all made sense in the end, right? Why the pouch came out still puffy, because the argon displaced the oxygen, and the normal vacuum, the vacuum packing effect, I put that in quotes, didn't happen. And that's why I couldn't see the red, and that's why I was startled. Very interesting set of events, okay? If I had to do it all over again, I think I would do it the same way, except the next time I'm just going to have faith and I'm going to leave the parts in the pouch on the rack with the Fanzetti. You know we love you, Robin. Running for a couple minutes. Like, just have faith and let it do its thing, because A2, being an air quenching steel, it's a much slower process. It's not like you're yanking out O1 and you're jamming it into the oil before bad things happen. You have a little more time. So I would just let that happen on faith next time. And I have a funny feeling that argon purge will prove to be quite useful. So Carl says, so next time, purge with oxygen, not argon. Listen, I don't even want to think about what'll happen then. Yeah, or next time, not use the argon and let the process be the process. But I think the next time I do want to do the argon purge, and I do want to just let it quench in the bag. So there's the punchline is let it quench in the bag, because you want the parts to be well below red hot before you expose it to oxygen if you want to keep the finish. So these are the things that I've been playing with and learning. But I have to admit that gray color is very desirable. It's really neat. So kind of liked it. Anyway, so that was the story on those parts. I have some pictures here. Let's see if I could bring them up on the screen. I have another project pictures, which I'll show you in a minute. Yeah, here we go. So if you're watching the video, I am going to show, where's my slideshow? Oh, that's what the problem is. Stand by. Fumble fingers here is figuring things out. There we go. All right, so there's if you're watching the video, there's the picture of the part, and that nice gray. Yeah, I guess I don't have those pictures handy. Okay, so that was the lesson from that heat treating. Now, the other lesson from that heat treating is that when I took my parts and I went over to my VersaGrip jaw, they didn't fit. So immediately I said to myself, I didn't account for growth from the oxide layer, and I didn't account for growth from the A2 growing, because we know it does. So I want to talk about that a little bit. It turns out, I'll give you the punchline first. It turns out that these are probably not part of the equation, but it was worth going back and revisiting it. When you do heat treating and you're at the mercy of all these data sheets online to help you figure out what you're going to do for heat treating, you start learning some interesting things. So first of all, this is sort of a hardness versus toughness graph that I used, and I got conflicting. I had probably 3 different versions of this hardness versus toughness versus tempering temperature graphs. Who do you believe? Who do you believe? I mean, they're all different. So I tempered at 500 degrees. I had other resources that showed there's a hump in the toughness curve on A2. On the graph that I just put up on the screen, that hump is happening at 600 degrees. Another set of graphs had that maximum, not quite the same shape, happening at 500 degrees. So after all, reviewing all the data, I decided that I would temper at 500 degrees because I needed toughness. And if I had to do it all over again, well, we'll see. I haven't finished all my testing, but we'll see. But what I'm trying to show you here is that these graphs are all different depending on who you talk to. Okay? So here, for example, is a size change per unit length versus tempering temperature. And you'll note that if we go to 500 degrees, there's a little hump there on this particular one, and it's somewhere between 3/4 of a thousandth and 1,000th of an inch per inch. That means that the A2 is going to grow as a function of tempering, and how do we say this? As a function of the whole heat treating process resulting or ending in a tempering temperature of that, okay? So it grows, and the reason it grows is Martensite, which is the crystal structure that we want after heat treating, is bigger than austenite. So that's fine. But A2 is actually pretty docile when it comes to this. And just look at the shape of that curve. Now, if we go to another curve, right, it's about a 1/2 thousandth per thousandth over the entire temperature range. If we go to another curve, look, it's totally different. Okay? Same thing, A2, same temperatures, totally different. So the problem is that it's very hard to get consistent data from the data sheets you find online. Anyway, so I picked 550 and I ran with it. Carl says, I think purging is not necessary considering how many moles of oxygen in the pouch versus moles of metal. I would have to generally agree with you, especially the fact that the pouch does its job really well. It's pretty amazing. And but it does. I mean, the vacuum packing phenomenon is absolutely real, and it's a very visual indicator that it's working. The oxygen is getting sucked out. Carl also asked, do you really need toughness? In this application, I do need some toughness because it is, you're shoving this knife, which is the edge of this gripper that I made, the round edge of this gripper, okay? You're shoving that into a piece of steel under pressure to hold it down. I didn't want brittleness, so I definitely wanted toughness. So I wanted to err on the side of tough. We ended up at Rockwell 60. The punchline is Rockwell 60, and the toughness will be measured by if I break any of them, which is why I made a dozen of them. So we'll see what happens. So to finish out this story, these came out measuring 752. Okay, 2,000ths over the target diameter. Is it possible that my heat treating and my oxidation combined resulted in that growth? And the answer is no. I took one of the parts, the one that went through. Let's see, my sample parts. Here it is. I took one of my parts, which went through the entire double temper. Okay, and I measured the diameter, and then I stoned off the oxidation from one side. Let's see if you can see that. Okay, and then I measured it again. It was essentially unmeasurable. So the oxidation wasn't the issue. And then if we look at, any of the resources we have available, they don't seem to indicate that it's going to change enough. So it's 2/10. This graph that's up on the screen right now says 2/10 of an inch per inch. This is not an inch. This is 3/4 of an inch. Let's just put it at, on the order of 2/10, right? Well, 2/10 is a lot smaller than 2/1000. Yes, Carl correctly points out that toughness is measured by Sharpie. Understood. We'll get to that. Or we won't get to that. We're talking the same language. I needed to add a little error on the toughness side. So, based on the available evidence, at most, we would see 1/10 or 2/10 or 3/10 of change. At most, that's the upper limit of what we might see, and we're seeing 2/1000. So now I'm blaming it on the lathe operator. Yes, I'm blaming it on the lathe operator. So we blew it. So what's going to happen is this, and this isn't a big deal. I've done this before, which is why I had this tool sitting in the toolbox. I have a round bar with a ground end and a threaded hole on the ground end, and I'm able to hold these parts cylindrically, put it in a spin jig, and we'll do rotary grinding on them. We'll kiss off that 1/1000 of an inch, bring it right back to nominal. It'll get all shiny again, and we'll be back in business. So no big deal. It'll take a few minutes of grinder time. Jamie Williams asks a magnificent question. Why does the stainless foil sometimes fuse itself to the heat-treated part during the process? I know half the answer to that question, Jamie. The process of this vacuum packing, right, where the oxygen gets scavenged and the bag literally sucks itself down to the part, puts it in close proximity, very, very tight proximity to the part. Why there is this fusion between the 309 stainless and your A2 steel or your knife steel part, I'm not exactly sure. But you're at these elevated temperatures. It's not very surprising. So here's something else I want to contribute. And I've mentioned this before, but not with as many people listening. So I want to tell you this again. I called my friend John Grimsmo. I texted with him, and he said that they use talc. This is not uncommon. They use talc in the pouch to prevent the sticking of the pouch to the knife blades that he makes. And I thought that was a pretty cool idea. So I looked around, and I didn't have any talc. Now, warning, if you go to the drugstore and you buy baby powder or talcum powder, you may be surprised to learn that it may not contain any talc. You must read the label. The other problem is it contains other stuff. So Grimsmo found one that he likes, and they use the talc. So while I was messing around with this on this other project with my lasagna noodles, I didn't have any talc, and I didn't want to go to the drugstore, but I did have a couple of pounds of 5-micron aluminum oxide lapping material, abrasive. And it was very much the same consistency as a talcum powder. So I did an experiment, and I took a brush, and I brushed on the 5-micron aluminum oxide onto my parts. Interestingly, it behaved like powdered sugar. It stuck to the part. We're talking a dry clean part, dry clean aluminum oxide 5 micron material, and it stuck to the part. Can't explain it. Worked great. So I would paint the parts with a little bit of this 5 micron aluminum oxide, shove it in the pouch, do my normal process. Nothing stuck to anything. It was beautiful. So my now and forever recipe for if I'm worried about parts sticking is I use 5 micron aluminum oxide. I do not use talc. The other thing is 5 micron aluminum oxide is going to not change at all at the temperatures that we're operating. So talcum powder is going to have some other stuff in it that might oxidize, burn, change, whatever. Aluminum oxide isn't going to do that. So Wes suggests static electricity. I don't think so. I think it was a mechanical thing. I don't really know. I can't explain it, but it worked great. So I will be using that forever now, and I've passed that along to others. And the material's not expensive. So that's the story. So we got up to the point of finishing this heat treating process. I'm about to rotary grind these guys, and then they're ready to drop into the vice jaws for the B200 production, and I can get right into my B200 production. So I'm quite happy about that. Brown or white? Flat Lapper says. You mean the aluminum oxide? Or what did I miss? Clarify. Please clarify. Clarification is required. Oh, you mean the sugar? Don't use sugar. I was using that as an example. The aluminum oxide is dead white, and it is. I bought 5 pounds of it from McMaster Carr for another application, which I won't get into, but I needed that sized material. Interesting. Greenwood AG says, your local John Deere might have talc if you want to try. It's used while planting to help seed flow. I'll have to check the label to make sure it's just talc. So talc is nice because it is a soft crystal, right? It's a mineral versus aluminum oxide, which is hard. So that doesn't bother me. I'm swimming in abrasives, so yeah. But seriously, if you have any 5 micron aluminum oxide, try this. It was magnificent. So that's the story on the gripper parts and some more lessons in heat treating. I was very happy about it. You know, if we do this stuff and we're kind of learning as we go, it's worth it, right? Oh, let me show you a picture. I only have one picture of the the B200 balancing ring production. This is the soft jaw of the B200 balancing ring production. This is the second station, okay, where you've done one side and now you flip it over into soft jaws. And anyway, that's all ready to go. I've posted pictures of that on Instagram. So the other project this week was this. I bought a Schar's tool holder for my lathe. Any problem removing the aluminum oxide without scratching? Well, I'll have to say no, because you're coming right out of heat treating, and I can assure you that anything that a 5 micron particle is going to do is a lot smaller than the surface features on something that just went through heat treat. So 5 micron is really small. I mean, literally think about powdered sugar. That's what we're talking about. So the next project was this tool holder. So I bought this Shars tool holder for the lathe, and this came about because of playing with some lathe stuff this past week. And I said, I know that my tool post is a CXA sized tool post, and I wonder if I could spend $35 on a Shars holder versus, well over $100 for a Dorian holder and have it be useful. So I go on Amazon and I push the button and I got a Shars holder, and it comes in, and if you're watching the video, there's the picture. And the inside of the rectangular cutout in the tool holder looks like it was cut with an axe. It was pretty gross. So I decided I was going to improve it and grind it. So that I did. Let's see. We'll go this way. So I eventually ground the what would be the inside surface and the bottom surface. That's all I was looking to do. But I also ended up putting a relief groove in the corner, and I ended up using these aluminum oxide fiberglass reinforced 0.62 thick wheels to cut the groove, and it worked spectacularly well. Now, again, I gotta blame the grinder operator. The first time I cut the groove and I thought I was done, I was not done. I didn't grind it deep enough. So I did go back onto the grinder for a little in deepening. That's almost as good as your gettering. So I deepened the groove, and it came out great. Now, between the time I cut the groove for the first time and then decided I needed to go deeper and put it back on the grinder for the deepening, there was some chatter on Instagram between Robin and someone else, I don't remember who it was, about the fact that groove should have a radius on it so it's not a stress riser. So having been so shamed, I took my here it is. This is a Norbide stick. A Norbide stick looks like a completely innocuous little rectangular kind of lathe tool shaped rectangular stick of black stuff. And it costs like $70, okay? But a Norbide stick is a very hard material. It's used for hand dressing grinding wheels. So I took the Norbide stick and actually dressed the bottom of that grooving wheel, and I put a little radius on it as best I can. It actually wasn't that easy, but it was good enough to allow me to sleep at night and not worry about the stress riser. Also, I should point out that the Shars grind on the dovetail side of the tool was pretty good. Like, it was totally adequate. And I was depending on that to be my reference. So I accepted the Shars grind on the precision side of the tool and proceeded to add my surfaces. So here's a picture of it's a wedge lock tool post, right? So the wedge comes out and it jams in, and what the net effect is it pushes the tool into the tool post. So the tool posts have sort of two mechanisms. One is a piston. They call it a piston lock, and then there's the wedge lock. The piston lock pushes the tool post away from the tool pushes the tool holder away from the tool post so that it locks up against the inside of the dovetails. The wedge type pushes the tool holder toward the tool post so the flats register against the flat of the tool post, which is more secure, more desirable. Greenwood says the groove is cut by a kid using a dull beaver. That's what it looked like. So So the grind that they put on it looked pretty decent for the application. It was the side that's holding the tool that just was horrible. Here's a top view, if you're watching the video, a top view of what it looks like for that thing to be on the tool post. So it came out great. I got my grinding done. It's satisfied my need to not leave well enough alone, and now I feel I can go ahead and use this. What's the bottom line? The bottom line is, yes, I can buy a $35 tool holder from Shars and make it useful, but I have to spend some time on it, to do that. Whereas when I spend more money and I get something from Dorian, it's ready to go. So, do you get what you pay for? Yes, you do. I also have a bit of a beef with the overall saying of you get what you pay for, because the full saying, which everybody forgets, is you get what you pay for or less, but never more. So that project happened and was done. So I'm going to turn my attention to any questions you might have, but I got questions this week that I want to spend a little time on in this segment. And one of the questions I got was something we talked about on other PFG lives. Oh, how far out was the Shars? So, how far out was the Shars? So if I indicated the bottom of the tool holder, so after I picked up, well, let me explain. I took a pin and I put a pin in the groove of the dovetail, and I held it there with a rubber band, and I indicated that pin in order to get aligned with the dovetail. Once I did that, I used that to side wheel what is the bottom of the tool holder rectangle, right? The place where your lathe tool goes. After I did that, I indicated the bottom of the tool holder, which isn't used for anything. It was at least 5 thousandths out from end to end. So, the outer surfaces of the Shars tool holder were definitely not useful for reference. They were terrible. And I was very, very tempted to also put grind the reference surface on the bottom just so you'd have access to a reference surface. I decided not to do that. But I did what I needed to do. 2 surfaces and the groove, and I was happy. So it also was pretty hard stuff. And the surface treatment, the oxide that was on the surface, it was wicked hard. It ground fine, but there you go. So if you need to make something special and you're going to grind on it anyway, sure, buy one. But it was pretty obvious where the quality was. Okay, so moving back to this other topic. So the topic was, how do you hold stuff that is not flat? So you may recall when we met our heroes a while back, I had started grinding these tools that I had designed with and for. Hang on one second. I'm just going to turn that off. One of our good buddies, and it turned into a project. And I needed to take this A2 tool steel, right, and grind it flat. Well, if you look at what came out of my heat treating oven, this was not flat. This was lasagna noodles, and that led to a whole bunch of lessons. But what I want to talk about is, how do you hold something, and this is one of the lessons, how do you hold something that's not flat in order to grind it flat? And the problem is that if you put it on the magnet and you turn on the magnet, it's going to suck that thing down to as flat as it can be, even if it's bending the part to do that. If you then grind it flat and then you release the magnet, it's going to pop back to where it was, and then nothing's flat. So the net result is that a grinder will grind parallel. Okay? In the absence of a human, a grinder will grind parallel. It's not going to grind flat. Because as soon as you let go of that part, if there's any stress in it, it's going to ping, it's going to go back to where it was. Greenwood said, "This is interesting. I have a bunch of Schar's tool holders and I've never checked them. I usually indicate the tool. You may have opened the can of worms for me." Listen, I don't want to start trouble. Well, I kind of do want to start trouble. But it may not matter. Don't get me wrong. I'm not saying that everything I did matters, and it might not matter for you at all. But enjoy the worms. So we've talked in the past about ways to hold a part that is relatively stress-free. In other words, you're not bending the part while you're grinding it. Amongst them, but not limited to, the paper towel trick. Okay, Adam Demuth, who's a great machinist, and he's got a YouTube channel you should follow, Adam the Machinist. He teaches a few of these techniques. The paper towel trick is you put a paper towel down on the chuck, you put your part down on the chuck, you soak the paper towel with coolant, and you turn on very light magnet. And this is not a perfect solution, and Adam correctly points out in his video that this is like a 90% solution. Exactly how the paper towel does what it does, I still lose sleep over, but it works. Basically, you could think of it as a cushion, so that in the broad areas that might not be contacting the chuck, they have enough pressure on them to not get sucked all the way down. So you do that, you flip it over, you do it again. Eventually, you get the thing flatter as you iterate. Another method is to secure the part not with the magnet. And a good way to do that is with a cyanoacrylate. Again, Adam demonstrates this with a part where he puts the part down on the magnet is off, and he hits the corners with a cyanoacrylate adhesive, and secures it and does a light grind on it to get a flat. That's another great way to do that. So between those techniques, and of course another technique is to use a vise and clamp it in such a way that you do not induce any additional stress. That is a very wide open definition, but it is another way to do it. So you're using a vise, not the magnet, but still you got to be cautious of what the vise is doing to the part. I'm happy to report that using all of those techniques, we were able to help Chris out and make these magnificent straight edges, which came out just lovely, and they came out beautifully flat. And yes, these are the parts that came out nice after we made parts that looked like lasagna noodles. So those are some pretty cool techniques, and the super glue trick is not to be discounted. That worked fantastically well. Now that I've said all that, and that was pretty much a review because we've talked about that before, there were some hidden things in what I said. What I said was you're holding the part in a stress-free manner so that when you grind it, it doesn't change. The problem is, what if there are stresses built into the part? So a good example of that happened this past week. I received some grinder platens from one of my customers who I've flattened some grinder platens for before. Grinder platens are on belt grinders. The knife guys love these belt grinders. And behind the belt is often a section where there's a flat plate so that you can push up against it and get some pressure on it. Well, those plates wear out and they get groovy and not flat, and then they want them flattened again. So I've been helping out with that process for a couple of knife makers, and we did that last week. Well, those platens are, by my observation, are made out of mild steel and cold rolled steel. Cold rolled steel, by definition, has had stresses put in the skin of the steel. So it comes out of the cold rolled process looking reasonably nice compared to hot rolled steel, except they've put stress in for you. So even if you're not messing with grinders, if you're just in a mill, you know that if you take a piece of cold rolled steel and you mill off one surface, that thing is going to turn into a banana. And you have to flip it over, do the other surface. But basically, you're dealing with stresses that were put into the material. And that's a problem. So when I was trying to flatten these cold rolled steel platens this past week, I absolutely saw that effect. And it's challenging. So I had to flip the parts over. I ended up grinding both sides of the platen, which is what the plan was no matter what. But getting them in the end to be at the flatness that they needed to be took some effort. Were they perfectly flat when I was done? No. I could put them down on a surface plate, and by hinging and moving them around, I could tell that there was a couple of tenths, maybe even half a tenth of non-flatosity, but that was okay for the application. So this is a real challenge, and holding stuff with a glue is a good way to do it. But again, if you reveal an internal stress, it's gonna rear its ugly head no matter what. CJ Stevens says the platen on his 2x72 that he built is made by A2. Hallelujah. So one of the questions somebody asked was, why don't you just make the platen hard and it'll last longer? And my answer to that is, good idea. So maybe that's something we need to try for these knife makers is a piece of hardened tool steel for their platen. It's not super much more expensive, and it's going to last 10 times longer. So that would be quite interesting. Anyway, hey, I can't believe it. Just getting through these topics, we're coming up to the top of the hour. If you guys have any questions, now is the time to just fire them off into the chat and let us know what you got. To wrap up the lasagna noodle story, when I made these lasagna noodles, you'll notice that they were just like, it is not worth chasing this. So these were left as a cautionary tale, and we made another 5 blanks. Oh, you bought it online. Okay, so I guess A2 tool steel platens are available. Is that what you're telling us? That's good. And that is the right thing to do. I mean, I don't mind flattening platens, but boy, if I was driving a belt grinder, I would absolutely make those platens out of hardened steel, which is easy for me to say because I have the tools to do it. Well, anyway, so my plan for the remainder of this weekend is to finish up CJ Stevens minis. So I'll tell you a little story about the minis. So if you go to PFGstones.com and take a look at the mini PFG stones, that size stone was inspired by Aaron Walla, who I was actually texting with this morning. And he said, gee, I wish I had a smaller stone that I could put into my toolbox that doesn't take up so much room. And he was the inspiration. In fact, he got the first set of minis that I ever made and let out the door. So that's the story. We should probably call them Walla stones. What do you think? Or the Walla, the PFG Stone Walla. I don't know. Anyway, thank you, Aaron, for being the inspiration on those. And yeah, CJ, your minis will be shipped out tomorrow. I promise. Have I heard of carbide-tipped straightening hammers? So I am familiar with the process of peening to straighten things out. And if that's what you're talking about, there's Aaron. He bows to the crowd. Thank you very much. If you're talking about sort of a peening process for straightening, I'm familiar with the process. I suppose you would put carbide on it for a reason. You're welcome, Aaron. How big of a radius do you suggest for a tool holder corner relief grind? Is 1/32 radius sufficient? I didn't put much science into that. I think I have a 1/16 inch wide wheel, so by definition, it's going to have a, on order 1/16 inch radius. Anything sufficient to clear a sharp corner is going to be okay. Too much is going to remove material and make it weak. So as small as you can do it, have a radius, and clear that sharp corner. By the way, that last part, clear the sharp corner, I needed a little more. That's why I had to go put it back in the grinder. That's pretty funny. By the way, I read, I want to recommend a couple of books, or at least one particular guy. This gentleman named, I know I've said this before, okay, again, hashtag not sponsored, Laren Thomas, Knife Steel Nerds is the name of his channel. Give him a follow. I think his stuff is excellent. Yeah, Aaron's correct. So those cutoff wheels that I'm using to make that groove, they're going to make a radius anyway. They're not making any kind of sharp corner. So I was going to tell this story earlier. I'll tell it in the super abbreviated form. My first exposure to heat treating and recipes and such came from the Bill Bryson books, right? Heat treating of tool steels. And then more recently, they came from Laren Thomas. Okay? Bill Bryson says if you quench your steel, you have to get it into tempering immediately. Okay? And he says you don't cryo it. You quench it as soon as it hits 125 degrees. You must temper. You must. Your tool will explode if you don't. It's awful. Bad things will happen. You will have halitosis. You will break out in hives. Laren Thomas says, yeah, as soon as you're able to get that quenched part into cryo, do it. You have 1 hour to get that thing finished being quenched. So I completely went against Mr. Bryson. I did what Mr. Thomas told me, Dr. Thomas told me, and it came out great. So, and that was, we air quenched until I was able to touch the parts, and then they went into the liquid nitrogen, and they went all the way down. So the quench effectively went from the high temperature, which was 1775, and it made its way continuously down to minus 300 or whatever liquid nitrogen is. Yeah, Aaron says that the cutoff wheel will generate at least 10 thousandths radius and usually more, and that's enough to prevent a stress riser, which we're really worried about. Although I did touch it up a little bit and make it a little juicier. Well, we've hit the top of the hour. You guys are awesome, and thank you for being here. It's been a fun week. Lots of learning happening, and that's the important thing. And I'll remind you, if you don't have PFG Stones, what are you even doing? Go to pfgstones.com and figure out what's right for you, and I'll help you out. By the way, all PFG Stones are made with these hands, 100%. So I wish you guys a fantastic rest of your Sunday, and I look forward to chatting with you again. I'm on Instagram at Spencer_Web_NH. And I'm on YouTube at Kinetic Precision NH. And this is also a podcast. So if you go to your favorite podcatcher and look for PFG Live, you'll know it when you find it. You can listen to the audio at your convenience. Hey, Chris, thanks for being here, man. I appreciate it. Because, if you guys show up, it's a tax write-off. Kevin, nice seeing you. Carl, you're awesome. Thanks for being here. I know there's a whole bunch of people that listen to this thing not live, but when they get to it, and we respect you, even in the morning. Have a great Sunday, everybody, and we'll see you soon.